Myself, L. Sunil. I am from mechanical department, working as assistant professor in St. Martin Engineering College. Today we are discussing about the one of the topic. కెమెరా చూసి అంటే తర్వాత టాపిక్ వెళ్ళినప్పుడు అది చూడొచ్చు ఇప్పుడు మీ ఇంట్రడక్షన్ Myself, L. Sunil, working as an assistant professor in the Department of Mechanical Engineering in St. Martin Engineering College. Today we are discussing about one of the topic, that is Foundry, that is one of the major in the industry purpose to manufacturing the components. That is Foundry. In the Foundry, so it is the practice of doing the components by bulk amount of products. That is by casting process. That casting process is have one major advantage of metals. The metals, we have important property. When you heat the metal, it will get liquid, and when you cool the metal, once again it will become solid nature. So that you can see here, it is making the casting by molds, because the component you cannot be manufactured immediately by something that you have to keep in closed container or like that. So first we have to go for doing the molding. So that casting is one of the main component in all the industries where strength and leakage problems are required. In automobile industries like engine and creating the engine pins, piston rings, and in the industries like our textile industry, for production of the all the machinery components, and where the strength is required and where the lightweight and strength is more and more for today advance, whatever the upcoming days, we are going for this casting process. If we are going for the normal joining process, the component or machinery will be joined by the bolt and nut. Then there is a problem that there is a leakage of like such a situation, fluid and the pressure. See that casting is a process, already I told, manufacturing of the component. First, for manufacturing the component, there are two types of casting will be there. One is a blow molding, another one is a heat applying by melting the some metals. By industry casting process, we involving the melting of the metals and giving the time to solidification to produce the component. Here, see that first the mold. The mold is what? The mold are permanent and temporary molds. The molds are the exact replica or exact the dimension, the product of the original one. So that in here we use some of the components or sand, we will call as sand. There is a different types of sands are available for making this mold. So first we prepare the sand, we will add the different types of the bonding agents to create the exact bonding to which holds the whatever the component poured in that mold. After making the mold, we have so many components, means we have to give the runner, riser, because entire mold is made inside the sand. Means we'll keep one box, in that one only the mold is prepared. And already we told that this is the pouring of molten metal. When if you pour the molten metal in any of these properties, like we have evaporation property, the mold is made by mixture of the clay, silica and moisture content. So when the hot water poured in that, what happens? The whatever the water content inside that, whatever the mold, sanding mold, it will get vapor. Due to this vapor, there is a creation or creating of the pressure inside that. Due to that, there is a defect will be happen. Maybe the breaking of the mold, the irregular shape, there is no getting of exact dimension of this, whatever the component you want to manufacture. But this one advantage here is there is no limit or there is no size. You can manufacture any size of the component here. And the losses of this process casting also less. At only one disadvantage is that is the dimension, accuracy. Because we already told that the pouring of the molten metal inside the mold, it will be create the pressure inside. Due to that excess pressure, there is a dimensions are be irregular. Dimensions are irregular in this nature. Due to this one, there is a major problem in the dimension accuracy. And when we have the quality control, there is a loss of dimensions. You can see this mold is made by the sand. The sand that only available at the river of the bottom trust, or the some synthetic sand also we'll use, but the sand it's not have such a properties that can be bind or which withstand with the whatever the molten metal poured in that. For this one we'll use sand plus binders. The binders, they will give the better to with which holds the whatever the molten metal poured in that. Plus we'll have some additives that will help for the good better strength for the molding material. First, see that this mold is made by two. There is a two boxes are will be there. At the upper one we call as cope. At below we have the drag. Upper one we make cope, and below we have one drag. So this cope and drag, there are two separate parts. This whatever we have cope and drag, up if one single piece pattern is there, if it is a single piece pattern, then entire pattern is made in the drag only. If it is in the single piece pattern. If you have split piece pattern, then half of the part is made at the cope and half will be at the drag. This entire box, entire setup is placed on the drag board, where entire setup is made. And to separate this cope and drag, we'll pour the separating powder, where we can separate the two cope and drag. So before we already told that you have to pour the molten metal. That any different types of material having different melting point, depends upon that. Whatever the component you want to manufacture, it may be exposed to the highest temperature, or it may be exposed to the highest strength, or it has to withstand with the more cooling process. Depends upon the application. First we have to prepare the molten metal. That molten metal, first will go to take the raw material from the outside, and the required quantity and the required ratios, and will pour in the furnace. From the furnace will get heated. and it will form the molten metal. That molten metal will be poured inside that mold. That mold we have here the pouring component. The pouring component, that is the we have to create the guideway to reach molten metal into the cavity, mold cavity, that we call as a runner. We call as a runner. As it is going, running through the entire mold cavity, it will fill the molten metal. It will fill the molten metal. After that, we don't know. After that, we don't know that there is no invisible visual inside that. So another the we call as the cutter, we riser. We cut the another hole, or with the help of the gate cutter will make entire inclined one vent we call as a riser. We are pouring one side, we call as a runner. Another side, after it is filling, it will goes and rise in the riser. After that, we have to stop the pouring of the molten metal. This is the first step. When you pour the molten metal, it's a very red hot condition, and this all the sand and whatever the clay and the mold material is having the moisture content. Due to that one, what happens? The heat or hot gases will be produced. To remove these hot gases, with the help of the vent wire, will create the vent holes. Through that, all the gases, whatever the moisture content, will be removed to the atmosphere. Then there is no development of pressure inside the mold cavity. Whatever the component will made, that exactly will get in the same product outside of the industry. We can see here there is a so many processes are given here, how they are making the molten metal, and how they are making the product like casting casting process. You can see here. First, the person is developed or prepared the sand. After that, he make the pattern. Pattern is the exact replica of the original component. After that, he made the mold. After mold cavity will be prepared and kept one side, and another side there is a molten metal. With the help of raw material, it will get molted and will get poured in that one, and given the time for solidification. After solidification, the component will be manufactured. Component will be manufactured. So that after that, the person will prepare the sand first with the help of some binder material, and after that they will make the mold. After mold making, there is a casting, whatever the molten metal is there, that is poured, and the whatever pattern is prepared. The pattern is prepared. See, this has some advantage and disadvantages. We can, when you are going for the bulk amount of the component, we can go for the casting. This casting will be reduces the product cost amount for preparing or manufacturing the component. And already we told that there is no size and the limit of the any component can be here manufactured. Only one disadvantage, that is the here dimensional accuracy. Dimensional accuracy, and the melt that has more weight, and whatever the mold is cannot be capable to the withstand the component. And but there is no limit at all for this whatever the casting process. You can see here, after manufacturing the component, we have to go for the machining process. Machining process. Due to this reason only, that whatever the component produced having the less dimension, that has less dimensions. See, there is so many terms we can use here in the casting process. In casting process, when we have see there entire casting process, the names and whatever the parameters are named here. So before you want to make the mold, before you want to prepare the mold with the help of cope and drag, the entire setup we call as a flask. The component we call as a flask. In this flask, the spores and risers, runners, everything they will be kept. This is entire one is nothing but the entire setup is flask. That is flask. In this flask, first we can take only the bottom component, that is drag. We will take first with only drag, and it is split piece pattern. Whatever you are seeing here, that is a split piece pattern. In here, what we will do, half of the part will be drag and half of the part in the cope. Half will be drag and half will be in the cope. So that parting sand we call as parting sand. First we prepare the drag, half of the part, and after that we prepare the remaining will be in the cope. And already we discussed that when the hot metal is poured in the gas, the molten metal react with the moisture content. That moisture content releases the gas content. Due to that, pressure will be developed. We have to release those all the component outside. See here, there is a pouring cup where the metal will be poured in that, and there is a runner and a gateway will be there that will goes inside the mold cavity, and that will be filled. After that one, what we have here is some parting line. Parting line will be there at exact middle of the cope and drag, where pattern will be splitted half and half. The pattern will be splitted half and half. After that, there is a runner and riser will be made with the help of the cutting the sand mold, by cutting the sand mold by gate cutter. So there are two draft mold cavity. When you combine cope and drag, after that they will prepare the draft and mold cavity, and the core point is the center where we have to create the halo in between the any component. Means you want to manufacture any cylindrical or spiral any component, we have to keep this core where like a hard material or sand only, having the more and more binding, so that what happens, it won't be fulfill the entire component. The gates, these here will be the gates available. That gate will be allows the molten metal to fill inside the mold cavity. And the riser, it will gives us to see the cavity, whatever the prepared, it is filled or not. And there is a pouring bussing will be there, so where we can pour the molten metal inside the cavity. See, there are two types of mold. There are two types of molds are there. One is open mold, means you want to manufacture the casting component at the atmospheric pressure. Just if you mold the cavity and pour it by openly by atmosphere, there is no need of runner, riser and the gates, cutter and the any type of the vent holes, nothing is required, just it is open. When you make some component, you pour it the molten metal, so it is exposed to the environment, then whatever gas will form or anything will form, that will be exposed directly to the environment. The second one, where you required complicated product, where you required very complicated product like a engine parts, those we have to go for the closed mold. You can see these are the closed mold where we all the component can be manufactured in the industry by this one only. Because here what happens to we are using this products in some applications, and where like if you want higher strength like a special for the defense, all those material, so we have to go for the alloy materials, not for the normal steel or some like a copper like that. When you are going the alloy materials, then you have to mix different types of the metals or some additive extra particles, or we call as a reinforcement particles. In that way we are going for the closed molding process. Closed molding process. See some of the tools they are using for the molding process. We are having the shovel, we have riddle, trowel, vent wire, strike up bar, and we have bellow, all those things. These all the tools they'll use for the different purpose. We have shovel for take the sand from the and mixing with the sands, riddles if you want fine particles. You don't want any type of the sand particle they having like a stone bigger one. We want fine particles. With the help of the riddle we remove all the more dimensional whatever the stones outside. Trowels to pour the molten metal inside the cope and drag, and with the help of vent wire we can create the vent holes to escape the gases. Strike up bar will be used for the remove the excess material from the sand, the cope, and bellow after making the mold. If you have very finite particle of the sand inside or any dust is fall on that, if you cannot take by the hand, there is a two component. With the help of the lifter, and the bellow we can blow, or maybe with the help of a mob we can remove that particle. Strike of spike, or we have mallet for hammering, we have draw spike for to cut any type of the component inside the that mold, inside the mold. See, we have types of pattern here. We have different single piece pattern, means to make the solid component. We have split piece pattern to make the two components. We have gate patterns. The gate patterns we have to different to flow the different component. So many, means at a time we have to manufacture 10 or 20 or 30 or 40 components. We have gate pattern. You can see here single piece pattern. It is inexpensive, simple in type, and to only one component that will be made at the drag. There no molding is made on the cope. Only the entire pattern is the replica is on the drag only. Next one we have second one, that is the split piece pattern. The split piece pattern, it is half will be at the cope, half will be at the drag. Half will be at the cope, half will be at the drag. So after the manufacturing with the help of the mold, that will be combined and making the only single piece of the component. When next third one we have the gated pattern. When we have gated pattern where you want to mask or you want bulk components, you want to manufacture thousands of components at a time, then we are going for the this type of gated patterns, where at a time metal will be poured, so that after that with the help of the cutting, we can separate the different types of component. Next one we have cope and drag patterns. Similar has a cope and drag patterns. Here it is nothing but only one, that is gating and riser system will be attached. Gating and riser system will be attached. Next one we have matched plate patterns. This type of patterns we are going for using the metals like pressing, or where we have to apply more and more pressure, and component like engines, there where you require high strength, we are going for this matched pattern. The whatever the below and above, the plates will be with the help of pressure, the component will be made or mold will be made. Next one, we have loose piece patterns. So loose piece patterns are having the such that withdrawing the pattern just by releasing, or just if you hold by hand or single pattern, you can remove it. After that, we have that next one, the follow board patterns. So the already there is a board is made, just you keep like a cap and we can make the pattern. This type will be used for manufacturing the plates and the bowls more and more. And the last one, sweep it pattern, is nothing but identical or similar at the half and half. So with the help of the hand, just you can press it and sand will be there, and same as the exact half part we can sweep it and we can press it, we can get the entire pattern inside that. We can see that these all like a skeleton pattern will be there. It will made of skeleton pattern will be there. It's made of only thin layer of that, where we can manufacture hollow particle, or where we can make the pipelines like structure we can manufacture with the help of the skeleton pattern. With the help of the skeleton pattern we can make. See that there are different types of patterns we have. Those patterns can be manufactured in the help of this whatever the different foundry process. You can see here entire how the process will be manufactured inside the component. You can see first there is a board will be there, drag will be placed. After that, we can see that parting sand will be placed inside that. The one, it is split piece pattern. For that, they all the sand they poured with the help of a rammer. With the help of the rammer, they rammed the all the sand, and again they poured with the help of the shovel. That is shovel. This is a rammer ramming all the sands on that. How much will be there? After that, they will create all the excess removing of the what a strike up bar, and one part will be again they will keep runner and riser. After they will keeping the runner and riser, in the runner they will pour, and riser they will be goes out, again parting stand. The process will be same, and after finally we can make the pattern will be removed, and entire cavity will be manufactured. With the help of pouring that entire molten metal inside that, so we can get the exact replica of the component. So this way we can manufacture all the components in the industry, by this casting process. We have some more and more. We have properties of the molding sand. The sands may be a different type. They cannot be available directly in the your niche. For that one, we have synthetic sand, where manufacturing will be done perfectly, where high temperature and where we have lightweight material for modern days. With the help of this synthetic sand, means it's a natural sand only, but we can be have so many advantages. How much strength, different types of alloy materials we can go by synthetic sand. We will be artificially, we are adding all the binders, moisture, everything will be manufactured. But in the natural sand, we don't have any control, just we will be taken as a reverse sand. After that reverse sand, we can put on the only cope and drag, we can manufacture. And last one we have that last one we have the loam sand. That loam sand we have the just the loose, wherever we have loose pattern we will use a loam sand, where just like a we have dust particles, like we have the wooden powder, or the some grass material, the powder where we will use the loam sand. Means there the pattern wherever it's having less weight, and we have like a plastic, we have manufacturing the plastic with the help of blow molding process. and there we can use that loam sand. Due to this topic, we can conclude that all the molding process. Thank you.